Okay, so hi everyone. So welcome back to Plan 258. Okay, as you see in the screen, so today's agenda is about prioritization. So we'll discuss a few topics, mostly about Knapsack, and then multi-criteria decision making, and I think we can please Brown keep some method. Yeah. So if we can finish, we can start with AHP, the character process. And I think this part will be next week. Yeah. Otherwise, these two part next week. Okay. So the slides is in Moodle, so you can check there. Okay, so start the first part. Yeah, so our topic today is prioritization and decision making. Okay, so we move from last time complex mathematical optimization, right? Using linear programming. Okay, and today you go to personal time management. Okay? So uh, this in this slide, this is the three topics that discuss. Yeah? So one is the basic prioritization. Okay, so you probably know about quadrant of importance and urgency. And then we go to optimization of the prioritization based on Knapsack. And then we discuss prioritization as a project. Okay. Okay, let's start with the basic prioritization. So first, why? Why do we need to prioritize? Okay. So the core problem, we have limited resources, right? You have limited time, you have limited budget, you have limited personnel, right? So the objective is to allocate these resources, okay, to achieve greatest impact, okay? So that means is also provide some kind of accountability and transparency, okay, why you make that decision, yeah? Why specific decision were made. So, so we need to keep track, okay, say the scoring or the factor that we use to make decision. Okay, say you have many projects, whether it is personal project or a transport project or environmental project. Okay, so then you make decision, right? So this project is prioritized. Then the question is why. So other people may have different type of prioritization, but how are we going to make agreement? Okay, so let's start with the personal level. Okay, so IU is important urgency quadrant. This is called Eisenhower Matrix. Okay, so this is in the personal level. So every day, okay, for me, I will make list of what task I will do today. So you also do like that. Okay, so and then we make prioritization, yeah, based on the list that things we need to do. Okay, so and then we put priority A, and priority A is urgent and important. Okay, so we do this first. Okay, and then priority B is not urgent but important. So this is what we need to do next. Right? And then we set the one that in the list, yeah, urgent but not important. So if the time permit, we will do this. Okay. And then not urgent, not important. D. And so usually this is something about entertainment or etc. Yeah. So if you will do this if you have time, right, in your working hour. Okay. So okay, let's do a personal practice for your own planning. Okay. Um, can you just list down your own? Okay. Say the list of tasks that you will do next week or tomorrow. Okay. And then can you set priority to be A, B, C, or D? Okay. And then after you make the list, okay, can you estimate how long for each of this list you will do each of the activities? Okay. And then estimate the value. Okay. You set an ordinal value, say 0 to 100. Okay. So 0 is the worst, then 100 is the best. For each activities in your list for tomorrow or next week. Okay. And then uh, set how long you will do these activities, all of this. And then you sort which activity should be the priority given the limitation of your time. Yeah, for the other. Can we do this in how many minutes? 5 minutes, probably. Huh? Okay, I will I will pause the recording. Oh, anyone want to share? Yeah, if it is not too personal, you can share. But if it is personal, don't need to share. It's fine. Okay. Anyone? Okay. So it's personal. Okay. Then okay. Basically, this type of technique, yeah, is very simple, right? So you get the uh, list, okay, and then you just put uh, prioritization A, B, C, D. Okay, so very simple and easy to use. Okay, what's the problem? Yeah, it assume equal weight. Yeah, in the important and urgency. Okay, and there is one critical flaw of this technique. Yeah. One is the time component. Yeah. In reality, long-term important tasks, so priority P, should often take priority over the short-term urgency task, yeah, priority A. But the matrix does not show this mathematically, isn't it? So it seems like A is higher than B. But in reality, if you focus on the long term, okay, you're supposed to prioritize B, not A. Yeah. So A is like short term urgency. And we probably need more criteria. Okay, so not just two criteria with this important urgency. And probably we need to put more weight for each of the criteria, isn't it? Then what are the possible criteria? Okay, so since the simple matrix, Eisenhower matrix a while ago, is flow, okay, so we need multiple criteria, okay, so then these are the significance criteria, yeah. So you can a while ago we have important and urgency, yeah. So these are the definition that I can put in. Okay, but you probably also need to have time horizon, isn't it? So say you can have how many, five or six values, okay, from very short term, mid term, until very long. Yeah. So, and then you can also add many other criteria, your own. Say, for example, is it necessary? Yeah, how useful it is? Okay. What is the potential result of this idea? Okay. And probably you also want to add how simple it is, yeah, how easy to do this idea, or depends on your own capability, yeah, if it is possible or not to achieve what you want. Okay. Other criteria that you can also include probably how interesting it is. Yeah, if you really like what you are doing, then you probably have more motivation. Similarly, with curiosity and satisfaction level. Yeah. So this is a personal criteria that you can add for any of your list. Okay, or you want more objective criteria, yeah, like cost and benefit. Okay, so these are uh, you put all this in transform this into money. Okay, or you can also add your own confidence level, yeah, on this list of tasks that you put. Okay, so anyway, these are all the usual or the common criteria that you can add. Yeah. Okay, any other criteria that you want to add aside from the one that I listed here? Any idea? Probably. Yes, Andrew.
Sir, maybe the if we are focusing on the greatest impact,
Mm-mm.
maybe we should also consider
The impact.
the projects that are most accessible. So
Okay.
it will have greater impact, or more people appreciating the project.
Okay, that's good. What else? What other criteria that you can add? Probably some ideas that you can think of.
Sir,
Yes, yes.
I'd
Go.
like to add
Yeah,
the opposite of what I said. Also, the less accessible areas should also be prioritized because they are marginalized
correct.
and underserved.
Yes.
So, sir, how do you grapple with that dichotomy?
Exactly. So, how are you going to grapple with this kind of dichotomy or certain trade-off that you need to put, right? Exactly, this is the area of what is called multi-criteria decision making. Okay, if you have contradictory criteria, one supposed to be up and the other one supposed to be down, right? Then how are we going to uh, make decision? Correct. Exactly, that's the exact problem that we I want to see here. Okay, so to get certain idea, okay, about this, I want you to read the story. Okay, so this is the uh, philosophy versus the mathematics. Yeah, so we are going to move from a subjective criteria, okay, to the actual optimization, yeah, using accelerator, yeah. So, uh, can you read this first? Okay, this is very common things that you probably often read in the internet, yeah. Probably some even give you the story. Right. So the golf ball is the important things in life, right? Like family, health, and so on. Okay. And then the pebbles represent the tangible assets. Yeah. So the job, the house, and then the sun represent the small stuff, isn't it? Okay. So the lesson here is if you put the sun in first, there is no room for the big things like the golf ball. So then you need to prioritize the big things first, isn't it? So nice story. Okay, good. Question. Is this optimum or not? Okay. So yeah, the story seems very nice. Okay. So question next is uh, yeah, the strategy suggested to fill the time with the most important, right? Things first. Question is this actually the mathematically optimal strategy or not? Okay, so the reason I put here is so that you will see, okay, what people say, yeah, and what the objective value is not necessarily the same, yeah. Okay, so people can give opinions that what the mathematics will be totally different. Okay, later we will see. Okay, so let's create a counter example, and then I want you to practice. Okay, very simple numbers. I want you to practice. Okay, so most people will agree, right? Yeah. So with the wisdom, yeah, quote unquote wisdom from the philosophy professor above. Okay. The way it was presented is very nice. Okay. But let us use numerical example to compute. Okay, I give you the numbers. Okay, so and then let's see the counter example. Okay, if that wisdom is actually optimal strategy or not. Yeah, so the story is wise philosophically, but it is often mathematically inefficient under the constraint. Under the constraint, that's the keyword there. Yeah, so we will prove. Okay, using a numerical counter example so that you will see. Okay, so can you type this in your Excel? Uh, we will practice this anyway. So can you type this? I have how many? Three, five, seven. Yeah, I have seven activities. Let's name this A, B, C, D, E, F, G. Okay, and can you just type these two columns? Yeah, of effort and important values. This represent the cost and the benefit, isn't it? Okay, so so the reason you need to type this so that we can have common numbers, yeah, so that we can have discussion. So if I'm wrong, you just bluntly say no problem. Okay. So what is the constraint here? What is the constraint?
Having only 10 hours per day.
Exactly, exactly. So you have only 10 hours per day for your daily activities. Okay, exactly. So can you use linear programming for this? Well, not in the calculator, yeah. In Excel you can. But why can? Because this is actually a discrete change. Yeah. Okay. Anyway, did you finish typing? Done. Okay. Okay. Let's compute uh, each strategy. Yeah. Let's try one by one. Yeah. All the strategy that you want to do. Okay. So number one is the most important only. So you this strategy number one. Okay. most important only. You do only the activities with the most important values. So how do you do that? You sort your table. You know how to sort in Excel, right? Okay. You sort the tasks based on the important values. Yeah, the values. Okay. And then what you do? You select the first few activities until the time is up, isn't it? This is the time. The time is an effort. Okay. So after you sort the value, and then what you do, you add. Yeah. 3 plus 5 is 8. Plus 2.5, oh, not enough time. Yeah. Maximum is 10, isn't it? So then you only do activity A and B. The rest you will not do. Yeah. Why? Because the time ran out. So for today, you will only do two tasks. Yeah. So question, how much is the total value? 10 plus 9, isn't it? 19. Record ya. Strategy one, most important only. Ah, so the total time is 8. The total value is 19. So record that. Is that fine? You know how to sort, right? Yeah, and then you just sum. Okay, up to 10. Yeah, so 3 plus 5 is already 8. If you add with 2.5, what you will do? No, it's more than 10 because we have constraint of 10 hours per day, so we cannot do activity C. Okay, let's go next strategy. Okay, this is what the strategy of the philosophy professor a while ago, isn't it? So he said, fill the big rock first. Yeah. So the method is fill with the most important, like before. Okay. Then use the remaining small gap for the smaller items. So again, you will do exact sort the same. You sort the value like a while ago. You do 3 plus 5 is already 8. Then you find, okay, which one the next one that can fill up to the constraint. Okay, the constraint is 10, right? So then you add with 2. So the total time now become 10. So you will do F. The total value is 10 plus 9 plus 5. So in that case, you get 25. Okay, 24. So record, okay? So if you do the second strategy, okay, type it in your table. The most important value first, then spend the rest, okay? Okay, that will give you total time of 10 and total value of 24. Are you still with me? Okay, let's go to the next strategy. Okay, we try another technique. Okay, which is the most challenging. Yeah. So you like challenge? Okay, let's do the most challenging first. Meaning you do the hardest, the longest task first. Okay, what you will do? Your table you sort based on the effort, not based on the value, but based on the effort. Okay. After you base on the effort, then you sort the second level based on the value. Yeah, in Excel you can do that, right? You sort first with the effort, and then the second level of sorting is based on value. Okay, then you select the first activities. Okay, until the time is up. Yeah, the constant is 10. So in this case, you have 5 plus 4.5, 9.5, right? Because the next one you cannot. Then total time is 9.5. The total value is only 16. So you get less value. So this is actually the worst strategy so far. Yeah, A, B, C, or the 1, 2, 3. This is the worst strategy. Yeah. Are you okay? Okay. In that case, because this is the most challenging, right? So we want to reverse. Okay. How if we do the easiest first? Okay, let's do how are we going to do the easiest first? Yeah, it's the same. So we sort the effort first, yeah, but not from the largest to the smallest, but we sort from the smallest to the largest. Okay, so there. After that, of course, you sort the value based on the largest to the smallest. Yeah. So okay, so you sort first the effort, smallest to the largest, and then the value from the largest to the smallest. Then let's compute, yeah, until 10. Right? So in this case, 1 plus 2 plus 2.5 plus 2.5, this is 5. This is already 8, right? So if you add with 3, that's more than 10, so cannot. Okay? So in that case, now this is the red part here is the one that you do, yeah? GFCE. Okay? So the total time is 8, the total value is 23. Oh, increase, no? Oh, but still lower than the last time, 24, isn't it? Okay? So meaning if we do the easiest first, yeah, the quick task first, this is what we will get. Okay. How about if we make a new strategy? How if we flip? Yeah. So we fill up the time, okay, from the higher value. Yeah. Okay. So we create a threshold approach. Yeah. So if we eliminate the task that is too hard, for example, uh, above 2.5 hours. Okay. So then we pick up the best of the rest. Okay. So we do the most important value after eliminating the difficult effort. So why? Because some people use their fear, yeah, to decide strategy in their life. Okay, so they use combination of strategies by setting certain threshold inside, inside your mind. You put actually you have a threshold inside your mind. Okay, if this is too challenging for you, so you stop. Okay, that is the fifth strategy here. Yeah, if the effort is too much, then you will not do, regardless the value. Okay, but if the effort is smaller than the threshold, then you will do the activities. So how you will do this? Yeah, so uh, exactly the same. Okay, so you fill up. Okay, and by setting the threshold 2.5, okay, so you remove all the effort that above 2.5. Yeah, after that, of course, you can uh, see the remaining values. Okay, and you will see uh, you get four activities C, E, F, G with total 8 of 8 and total value is 23. The same as earlier. Yeah. Yeah, of course, this depends on the threshold value that you set. Yeah. Okay. Uh, the next, okay, well, this is the last strategy that I can think of, but you can also think other strategy. Yeah. So how if we have the fastest and the highest value? Yeah. So you aim for a low hanging fruit. Yeah. That means high value, low effort, right? Is it smart? Probably. Yeah. So by selecting the fastest but the highest value, yeah, that means you have the least time and the higher value is the aim. Is this really the optimum strategy? Okay. Look like, yeah. You see, you will get this 27. Wow. This is the best so far, isn't it? So can you uh, Think of other strategy that can beat this 27. Hmm. Any idea? Yes, Thomas.
Sir, if we remove the lowest or the easiest effort and
Mhm.
probably we consider the mid-level effort, so we can
Mhm.
get 29.
Correct. Right. So, so by trial and error, okay, you can do that. Yeah, you will get the optimum value of 29. Yeah. So the best strategy is actually 29, yeah, not 27. So the question is how are we going to get that optimum strategy with this 29? Systematically, not by trial and error. Are you curious enough to know? Right? And this is actually very useful, yeah? Not just for optimization on the personal task, but also for many other technique. Yeah. So human intuition often fail to solve this, yeah, perfectly because we struggle to visualize the perfect geometry of the value density. Yeah. So okay, let's go to the actual optimization. Yeah. So the strategy is known called knapsack problem. Yeah, you can search in Google knapsack problem. Yeah. You know knapsack? Yeah. So the story of knapsack problem or KP, yeah, is a hiker packing his knapsack, yeah, for his mountain tour. Okay. So he has n object. So this is the task a while ago. Then each object, say, yeah, name one, two, three until n, right? Each object have certain weight. Okay, so let's call this weight Wi. Okay, now and then each object also have certain value. Okay, so that value represent the profit, the comfort, the utility, some benefit. So let's call this V, yeah, value I. Okay, so then you have the constraint, which is the capacity limit. Yeah, you cannot carry more than certain weight C. Okay, so then your objective is to maximize the benefit. Okay, so how are you going to use LP, yeah, linear programming, for this, right? You already learned LP last 2 weeks, right? So you need to formulate this problem. Okay. Uh, I told you you cannot use the LP calculator. Yeah, you can use Excel, but not LP calculator. Why? Uh, because of this second variable here. Yeah, a second constraint here. Because the constraint must be binary. So that means discrete. Okay. The first constraint is fine. If you only use the first constraint, you can get using the LP, yeah, calculator. Yeah. But using the second constraint, you need to do it using Excel. Okay. So you maximize the uh, profit, yeah, with this linear programming. So this is the value multiplied by the X. What is X here? Hmm? Yeah, this is the items that you will choose. Yeah, X is the item. Okay, the X is either you choose or not choose. So that's why binary. Is that clear or not? Yeah. If the X is 0, that means you don't choose. Yeah? If X is 1, that means you choose. Okay. So X here is the items that you choose. Yeah. And then this is the weight. Okay, so given the V, I, the value, given the effort, W, and the constraint, maximum 10 hours, can you find which one you should choose and which one you should not choose? Okay, can you solve this one using your problem a while ago? Did you get 29? Okay, so I want to remind you, yeah, that KP, Knapsack problem, is probably one of the simplest, yeah, non-trivial integer programming. Yeah. Why this is integer programming rather than linear programming? Because the value, yeah, some of the constraint and the variables are not real number, but they are discrete. Yeah. Apparently, discrete is more complicated, yeah, than a real number. Yeah. So computational, this is called NP hard. Yeah. So it's computational difficult. Okay. Because when you solve this, okay, the number of items will grow based on the number of variables. Okay. So for that, I have my own software to solve this. Yeah, I call this antecedents. Yeah, with this Excel add-ins. So you can solve, yeah, and then you can get exactly using Knapsack. Yeah, you don't need this, but you can solve your problem a while ago using Knapsack. Anyone want to share screen if you have done this? Go ahead. Or you want a demo? Okay, let me create Excel. Okay, so this is my Excel. And let me copy and paste the table. Format. So why it doesn't? Let me remove. Okay, good. And this is the data. Can you see? Right? And then the constraint budget, yeah. Uh, total, yeah. Total effort, right? Is how much is the constant total effort? 10. Yeah. Then let's get the actual total here. Okay. Sum. Oh, no, I keep something wrong. Okay, so you see yellow meaning the input. This one also yellow, the input, right? Okay, let's go to the knapsack. Get the screenshot of that. put the screenshot here. Okay, so we need to multiply the V. Okay, so we need to get the X now. XI, okay, XI. I don't know. So this is the one that I want to know. So let's put 111 all. Is that okay? Okay, this is the one that we want to know, right? This is the one that we want to know. And then, so XI, we don't know. This is what we want to know. VI is here, right? So this is the VI. And this is the W. This is the WI. Okay. So what we need to get, we multiply WI times XI. Okay. So apparently we don't need this total. What we need is actually WI multiplied by XI. So that is the sum product, isn't it? Sum product. Sum product of what? This one and this one. Okay. There, this is the one that we want to know. Change it to green. So this is the first constraint. And this is the second constraint is binary, we will set. How about the objective value? The objective value is VI times XI. So let's put that here. P, yeah. So we will have some product again, some product of what? This one, yeah, the VI and the XI. There, that is two. We are ready to use the solver, right? So let's go to the data, right? You have solver. Yeah. What you will do, you want to maximize. What do you want to maximize? You will maximize the P, isn't it? Huh? Then, okay, what do you want to change the variable? The xi, okay? And then what is the constraint? The first constraint is this one, yeah, wxi, this one, the green one, must be less than c, which is less than our. Okay, and then you add. What is the second constraint? This xi must be binary, there, pin. Okay, and then click OK. There, can you see? Okay, and then what you will do, you solve. You get the solution. Okay, I will make this so that you will see the solution. I will make this colorful. The green one is the solution. Oh, you get the 29 here. Exactly. So systematically, you can solve this. Is it better? Any question? Can you do this? Can you get the result? Yes, George.
Sir, this highlighted green cell, these are the objects that he needs to bring.
Yes, these are the one that you will use. Yeah, A, C,
Okay,
E,
sir.
and F, right? Okay. And that's exactly in the slide, isn't it? There, in the slide here, I put, yeah, 29, yeah, A, C, and F. Okay, so I hope you start to appreciate the importance of optimization. Huh? Okay, so if you just do trial and error, yes, you probably can get. Okay, okay, but if your number of tasks is so many, you probably will get confused anyway. So we are doing it using a systematic method. So any comment, any question? Or anyone want to share your screen? Did you get exactly the same or maybe different? Go. No comment at all? Leah? Yes, Thomas.
Sir, how did you do the second constraint?
Which constraint?
Is it xi, is it summation or is it
The x element of 0 and 1?
yes?
Okay, so good question. So here, you go to the solver. Okay, this one, the second constraint, right? So I will show you. There. Okay, you go here.
Screen is not shared, sir. Excuse me.
Oh, sorry.
Thank you, sir.
You go here. There. Pin. Can you see this?
Okay.
Okay. Okay, you select pin mean binary.
Oh,
Okay. In mean integer. Yeah. Diff mean difference.
okay, sir. Thank you.
Diff mean all difference. You want to find unique value. Okay. When are you going to use this? If you want to do logistic of TSP, traveling salesman problem, you will use diff. Yeah, maybe next time, yeah. Or in other course, I don't know. Yeah. So, is this interesting enough for you? I'm not sure. Okay, what did you learn? Yes, Lester.
Sir, sorry, another clarification. On the formula used in the WI times XI, the
Mhm,
initial, which
mhm.
is also equivalent to 20.5 earlier.
Oh, this one. This is
The
like
green one, sir. The 10.
the 10. Okay.
Yes.
So,
Some product. Okay,
okay,
sir.
let's do that again. So, initially you have 111, right? So you get exactly the same. This one, this green one.
Okay, sir.
Yeah. What is the question, Lester?
I saw it already, the formula, sir. It's the sum product of
Oh,
WI times XI.
okay. So this is WI. This is the column. Okay. And then XI here. So you multiply, right? One by one. That means, well, you can do it one by one, plus, 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 plus. But there is already formula in Excel called sum product. In vector notation, this is called dot product. Yeah. So this sum product is the same as dot product. Okay. So you have two array that you can multiply and then sum together. Yeah. But in formula, you will get exactly this. Yeah. WIXI. This means sum product. Okay. Yes, Andrew.
Hello, sir. So I think the one that will be struggling with is formulating the formula.
But
So
this one, the maximize something.
yes, sir. So I'd like to clarify if I understand it correctly.
Mhm.
The first constraint, you formulated it such that if xi is zero, the effort will be zero also. So you're aiming to sum it only up to 10 hours. Is that you're eliminating
So
the effort?
let's do this all zero. This is what you want to say.
Yes. So you're
Okay.
eliminating the contribution of the effort by multiplying it to zero.
Okay. So you get all zero here.
Yes, sir. Okay.
Right. So if you put all zero, let's start with all zero. Okay. But you said, okay, I want to find xi in order to maximize my benefit, which is the total value must be maximized. Okay. In order so that the cost must be less than C. It is the constraint that you set, 10 hours. Okay, we can do that the same. So we exactly the same. Okay, I don't change anything here. What I will do is just click the solve button. You get exactly the same result. Okay, so yeah, so it's stable. Yeah, it doesn't change. Yeah, whether you start with zero or you start with one, okay, you will get exactly the same result. Yeah, A, C, F, and G. So, and then you ask how I make this formulation. Okay, this is actually the formulation of Knapsack. Okay, so remember a while ago. Yeah, so you will see over the time. Okay, I understand this is probably the most difficult part. Is actually from the actual problem to find this kind of formulation. Yeah, that's why they name it. They give name. Okay, that means this problem is so general that you can just use. Okay, and this is the formula that you can use. Yeah, when you will see, oh, this is called transportation problem. Oh, this is called shortest path problem, yeah, or longest path problem. So they name it. So that means they give you the formula. Yeah, this linear programming formula. Okay, so and it's generic enough. Okay, and then if you know the problem is similar to this, then you use this. Yeah, over time you will see a lot, and then you will see, oh, apparently I have many different kind of linear programming. Yeah, that it's a specialized linear programming, right? But once you use this specialized, you will see the benefit. Yeah, that's why they give name. Yeah, that's why they give name knapsack. Yeah, because it's really important. Okay. Yeah. So once you see the name, it's not just anyone can keep a name. Yeah, the name represent value, isn't it? Yeah, represent something that you can use and reuse. Okay. So I hope this is helpful for you. Any other question? Okay, let's go back here. So this is what you see. Yeah, that's a problem. Okay, and this is what you get. Okay, let's practice so that you can have a better understanding, isn't it? Okay, I give you this problem. Can you practice? Okay, say you want to hike and you can only carry 9 kilo. Okay, only 5 items. You just type this. Yeah. and each have particular value for the trip. Okay, which item should you pack? Yeah, so that the total value is maximum. Yeah, subject to the weight restriction. So remember, this one have maximum of 9 kilo. Okay, can you type this? Yeah, in the new sheet, yeah, you type this table or just copy and paste this table. And can you do the knapsack problem? Yeah, practice. So this is what I'm doing. So in the initial setup, okay, I will just do this. Okay. Again, this is the one that we type. Okay. And this is the constraint, right? Then initially you can put 1111 or 000. It's up to you to start. Okay. You know how to compute some products, right? So then you compute, yeah, WXI and then VXI. Okay, so you can type one by one to get this, yeah, the two. You put 00, they will get all 0. But if you put all 111, you will get 23 and 31. Okay, and then what you will do, yeah, and then you will use solver, yeah. So you get the total value, changing the XI, yeah, the total cost less than the budget, and then don't forget to put XI must be binary. Huh? Okay, then you're supposed to get this result. Oh, you will bring only two items, yeah, with the C and E. Do we get exactly the same or different? Do you think? Yes. Oh, you get the same. Very good. So you are familiar with that, Ryan? So, are you getting better? Yeah, you're master of knapsack already, right? Okay. Anyone want to share screen or if you have any comment, any question, or if you have any difficulty, so we can also share screen and we do it together. Did you get the same result? Okay, good. Okay, and then let's practice one more. Okay, I think this is, I think, more interesting. So you have a certain capital for your stock investment. Anyone play stock here? Okay, so of course you know the price, right, per stock. Okay, and you have potential return of investment, and you also know the value, yeah, that you can predict for the stocks. Yeah. Okay. Question is, how many stocks should you buy on its symbol? Yeah. This is a little bit different from earlier. Yeah. Earlier you have only pure knapsack problem. Yeah. In pure knapsack problem, what you will get is only yes or no, include or not include, binary. Okay. In here, we want to know how many stocks. That means you have integer, not binary. That's the exact problem. Okay. So I give you the yeah, this is the common, yeah, a wealthy individual or institutional investor. Usually they have a certain amount of money budget, yeah. So C, okay, and then we want to put into a business. Yeah? The same in transfer project is the same. Yeah, you have certain budget that you have, okay, and you have certain project that you want to invest, isn't it? So each investment will have the cost and the benefit, correct? Right. Okay. So WI is the cost, yeah. The VI is the expected net return or the benefit, yeah, over the fixed period of time. Isn't it? So of course you can include the risk, but that risk is actually already included. Yeah, we simplify, yeah, included in the net return here. Okay. So the question is, how are we going to invest? Yeah. So say, let's do this. Okay, I will just put this number. You just copy and paste. Okay, in your Excel new sheet. Okay, and you have a budget of 10,000. Okay, your capital, and this is the possible investment for this month. Okay, so A, B, C, D, E. This is the stock symbol. Okay, and this is the cost per stocks, and this is the expected net return per stock also. Not sure. Thank you.
Okay. Now we can see it, sir.
Okay, sorry. Yeah, you need to remind me. Okay, can you see this? Okay, so this is the numbers that you have. You just copy and paste it. Okay, so what's the difference? What's the difference with earlier, the pure knapsack? Yeah, the only difference is now the xi is no longer binary. Yeah, is integer. There. So this is the only different part. Yeah, this is the exactly the same. Okay, this is the only different. The constraint is slightly different. Okay, so you will do exact. Okay, so you type this. Okay, Excel, right? And this is the budget that you have. Okay, and then so you do exactly the same, only different numbers, and then uh, exactly the same also the solver setup, except this one, yeah, xi is no longer binary but now become integer. Okay, then you will see, oh, amazing. Okay, now you have it will go up to your budget, yeah, 10,000, right? And this is the maximum value. Okay, and amazing, right? Because you don't need to buy A and B and E. You focus on C and D. Okay, and D you need to buy 31. Yeah, C you will get 4. Yeah. Okay, so it is something useful. Tell me. If you have any difficulty, you tell me also what is your difficulty that you face and, in making this prioritization. Yes, Paul.
Hello, sir. On behalf of my group, may we request a step-by-step run-through again for this example only, the investment? Is that
Oh,
okay, sir? Thank you so much, sir.
yeah, so let's create the Excel sheet again. Oh, okay, so I'll just copy, yeah. Hmm. My mouse is a little difficult. Yeah, I will build the format. So I got this, and so that you can see well. So I put it like this. Okay, and then let's get the formula. Okay, the formula is important, right? Otherwise you get lost. So let's get the formula and put it here. Okay, so this one is W I, and this one is, what is this? This is the value, isn't it? So VI. Okay, what you don't have. Oh, what you want to get is the XI, right? XI. Okay, so XI is the items, yeah, number of stock. Okay, so initially you can put any number, yeah. So I'll put so that you can see 2, 3, 4, 5. Is that okay? I just type so that you will see. Okay, so what we need to get is VI times XI. So I need to get VI times XI, and then I need to get this one, WI times XI. Yes, WI times XI. So how do you get that? Yeah, just multiply. So this is XI, right? Multiply by XV. This is the V. Okay, and then this one is XI multiplied by W. Yeah. Okay, then we copy these two from C. Oh, okay, and then you want to get the sum, yeah? This symbol of sigma, yeah, represent the sum, right? So you get the sum equal to sum. The sum. Okay, so you get that value and this one. Okay, this is the one that we want to get. Yeah, so this vi times xi, so this is equal to the p. Yeah, and this is the first constraint. Yeah. Okay, so this is the green, and this is the different one. Okay, blue. This is clear. Okay, so you don't want to compute like this. You can just use some product. You will get exactly the same value. Yeah. So say I use some product here so that you will see. Okay. So if you use some product, what you will get? So you will get VI, some product, okay, of XI and VI. Right. That I exact. Correct? Exactly. The same value, yeah. Green and green. The same thing here. If you want to use some product, okay, so you will get exactly the same of XI and WI. Close. My keyboard. Yeah, exactly the same also. Okay. Then what you will do? Okay, you will do the solver. My screen is not sharing. So you will do the solver. How do you do the solver for this one? Go to data, solver. Okay, what do you want to maximize? You want to maximize the P, isn't it? So you set the objective to P, this one, K12, green one. Okay, set this maximize. What do you want to change? The value is the yellow one here you want to change. Right? And then you add. What is the add? The first constraint. The first constraint must be Wi times xi, the sum, this one, must be less than, how much is the constraint? 10,000, isn't it? 10,000. The second constraint, this one must be integer. There, integer. Can you see? Okay, and then you click OK. There. And you see the parameter. Oh, okay. So you get the objective K12, this one. Maximize changing this value I between 6 to 10, correct? And then integer and this one, okay, the value L of 12 must be less than 10,000. Solve. Get the result. Oh, I think you will get exactly the same. Oh, different result. You get different result. You get different result than the I get this different. No, this is different. Oh, there. Oh, the same result. So that one is the earlier problems, right? Okay, the same result, yeah. So you get 4 and 31. Okay, good. 116,500. Oh, I got exact same 116,500. Super. Is this clear? Okay.
Yes, sir. Thank you.
Yes. You practice so that you get the better understanding. Yes, Thomas, you want to say something?
Sir, can I ask a curious question?
Mm.
Do you use your mathematical knowledge in investing?
Oh, yes, of course. Otherwise, how can you make profit?
Okay. Thank you.
In fact, okay, so well, in 2012, I was working in the subsidiary of Goldman Sachs in Wisconsin, right? So that part have a lot of mathematics, yeah. So deep mathematics, not just this one. Okay, so that's why they are hiring mathematicians, physicists, and so on. Okay, not economists anymore. Okay, and the one that I gave in this course is practically just the basic, you know. At least you need to know this one, something like that. So once you get curious, okay, about this, then you start to feel, oh, I need to enhance myself. Then you start to learn on your own, right? Okay, but to trigger that curiosity is important. Okay, to motivate you. That's my goal. Okay. Uh, in fact, this is I barely touch the math at all, isn't it? I just give you the math, okay, and then we just use the software to use, right? So I did not even give you the derivation why you get that and so on. I did not even give you the how the program do the optimization, right? So okay, I barely touch the math. Okay, so but if you are start to see the benefit of this, right? Then you see, oh, this is apparently very useful. Okay, and if you are highly competitive enough, okay, then you start to encourage yourself, yeah, motivated to learn. Okay, not because I like mathematics, okay, but because I can see the benefit of the mathematics. Okay, and to stay competitive enough in the era of artificial intelligence, then there is no choice. You need to go deeper. Yeah, I hope this motivate you. Yes, Andrew.
Sir, what are your recommendations if we
Um,
want to go deeper
okay.
in the surrounding topic of this
Okay.
prioritization
So
mathematics?
you know there are artificial intelligence LLM. Okay. In the past, you are using Google. Okay, just search, right? But now you can use the LLM, and there are many, for example, in Gemini or ChatGPT, you can start to ask, okay, curious question, and then you pursue on your own. Okay, I want to know about this particular things. Yeah. So what I introduce you in this course, so many different type of methods. Yeah, just to trigger the curiosity. That's the main part of the motivation. Okay. Oh, I feel this useful. Okay. Then you ask more detail, right? Once you ask more detail, you go deeper on your own. Okay. And discuss with your AI. Okay. And within a few hundred hours of discussion, then you start to see that you probably more expert than me. okay, in that particular topic. That is my call. Yeah. If you are still lower than me, that's not good. Okay. So you must be more expert than in certain small topic. That's my goal. Okay. Don't look at this as, oh, this is high level. No, in fact, this is basic. Okay. You should go deeper than this. The tools is already there available for you. Right. So you should not just based on the curriculum, then I need to reach that curriculum. That's not the way to do. Yeah, you are below the basic level. No, you should go above that basic level. Pursue on your own, right? On whatever curious topic that you think this is useful, and you can ask. You can discuss why this is useful, why I need to pursue this, and so. Okay, use the tool that you have. Okay, the genie. Okay, so yes, later on you will see. Okay, wow, if I have this tool, okay, apparently I can remove the trial and error, right? Okay. Well, the example that I give is very little, only 5, 6, 7 items. So that's easy. Okay, but in real life, you will have more than two variables and many items that you need to select. In that case, yes, you really need the real uh, optimization. Yeah, I hope this trigger curiosity. I want to know more. Yeah, that's what I want from you. Yeah. Okay, so I just give you some clue. Okay, how are we going to do this for business application and transport? Yeah. So in logistic, yeah. So you have, say you are dispatcher of airline cargo, yeah. So you want to get uh, load the package to certain airplane, yeah. So then each package have certain weight, okay, and of course the every plane have certain maximum capacity, right? And then depending on your agreement with the customer, you will have the rate. Very good. Yeah. So you get the rate for per weight. Yeah. Unit charge. It's request. Yeah. Probably not fixed. That case, you start to check the profit. Okay. So this is exactly Knapsack problem, isn't it? Okay. So when you see this kind of story, you start to think, hey, I know this. This is Knapsack problem. I can solve this. Right? Okay. So another story, production. Yeah. So assume you have a sawmill. You want to cut the log, yeah, into shorter pieces. Yeah. So and then the pieces must be cut into certain standard length. Yeah. So let's call this WI. Okay. And then each length have certain selling price. Okay. So can you start to see this is actually NAFSA problem, right? Okay. The story is different. Yeah. Okay. The application can be different way. Okay. But once you see, oh, I know there is a certain cost and certain benefit and certain uh, maximum you want to maximize the profit, okay, and then there is a maximum to the cost, yeah, capacity, something like that, yeah. Then you will see, oh, this is not a problem, okay. So next, this one also can be used in academic. Yeah. So some of you are teachers, right? So you want to see that the students receive n questions. Yeah. So each question indicates the weight. Yeah. The number of points. Okay. Say total larger than 1 point, for example. And then the student will select certain subset of that question. Okay. So after the exams, okay, all questions are answered by the students and then graded by the instructor with certain points, yeah, VI. Okay. Then the subset of question is selected uh, to determine the overall grade, yeah, of the maximum number of reachable points. So this one is the cost, yeah, the reachable point is the WI, okay, so that it will go beyond the threshold, for example, 100. Yeah. So to give the student best possible mark, then the subset should be chosen automatically. Yeah. Okay. For the score. So again, this is just make up story, but you can see this is also an upside problem. Okay. Are you curious enough that we will go beyond this simple knapsack problem? Okay, I introduce you knapsack problem. It is the binary one. Okay, I introduce you application to the stocks. That means you change the binary into integer, right? So now in brief, okay, don't feel bad with the math. Okay, yeah. I will introduce you two more model, which is actually knapsack problem, but this is the variation. Is that okay? If you don't like this, just ignore, no problem. Okay, but at least you know there exists these two subset of knapsack. Yeah. So, uh, where is the? Oh, I did not put that. Okay, if I think I need to put it. Maybe I hide those. Okay, I hide those things. So this is optional. Okay. So this is the optional. So this is the upfront variation, optional. Okay, not include in the exam, but at least you know that exists. Okay. Some of you are master and PhDs, correct? This is probably will enhance your curiosity. Okay, so this is called multi-dimensional knapsack. Okay, so the question here is how if instead of only weight, you also have multiple variables, yeah? You also have volumes as the constraint. So instead of one variable, now you have more than one variable as your constraint. So if you have like that, this is called multi-dimensional knapsack problem. Okay, or multiple choice. So what is the difference? Yes, now your result become matrix. Yeah, it's not just an array. Yeah, now become matrix. Okay, so become Wij, and then the C, the capacity a while ago. Yeah, now depends on the variables. Yeah, Cj. Okay, so this is called multi-dimensional knapsack. Yeah. I don't know if you understand this one. So this is now matrix instead of one array. Okay, so the application, okay, if you have many other variables, yeah, to include. Okay, and Another variation of knapsack is called a multiple knapsack problem. Yeah. So how if you have multiple airplane, not just one airplane, to carry all the packets in parallel? So in that case, you want to know which packets go to which airplane. This is more complicated, yeah. So if you have this kind of complicated problem, then you create this formula. Look at this. What's the difference? Okay, the difference now. The x a while ago was xi. Okay, now you have multiple knapsacks. Okay, you have different airplane. K. So x instead of xi, now you have xik. If you have two subscript like that, that means you have a matrix. Okay, so everything is the same. Okay, similar. Yeah, but now the xi is now xik. That means different plane. Yeah, so this is the variation of knapsack. And another variation of knapsack is called multiple choice. Yeah, this is the third variation of knapsack. Yeah, is multiple choice knapsack. So in that case, you have only one knapsack. Okay, but you group. Yeah, the items are grouped into tools. Yeah, and then each tool has several variants of items. So you have kind of hierarchy like that. Yeah? So the objective here is to select just one variant of each tool. Yeah, you select the groups. Yeah? So that the overall utility value is maximized without exceeding the capacity constraint. Yeah. Yeah. So in that case, what you will do, yeah, you have now introduced group, yeah, GT here. Yeah. So you have a set different variants of the group tool, T, yeah. And then now the XI now become XIT, yeah. That means that you select the variable to select the items or the tools, yeah, for each variant I, yeah, based on that group tool. So if you have a multiple choice, then this is the formulation. Yeah. Yeah. Do I confuse you enough for this? Yeah. Yeah. Okay. So let's go back to the actual things. Yeah. So this is part of the curriculum. So transport project prioritization. Say you have a transport project, okay, and you want to quantitatively involve some numerical data, some objective criteria, okay, and then you want to run the project, okay, based on the benefit, the cost, the impact, and so on, okay. So you have many multiple criteria, okay. So first, of course, you need to define your criteria, right? And probably you need to collect the data for each project and then for each criterion, okay? And then you need to put the weight for the criteria, okay? And then you score them, yeah? What is the score for each project, okay? And then you calculate the total score and then you run project, yeah? And then you review. These are the usual, what is called multi-criteria decision making, right? So, of course, the criteria should reflect your goal, yeah, the objective that you want, isn't it? Okay. So, for example, the cost, the travel time, saving, riderships, okay, safety, and so on. Okay. Social equity. So these are the criteria that you can set up. Yeah. And then you can also uh, add some intangible factors, yeah, like qualitative factor. Yeah. So not everything fits into the quantitative. Yeah. So you can also add community sentiment, biodiversity, yeah, maybe political will, yeah, maybe aesthetic value, yeah, along with the objective factors. Right. So then you need to balance, yeah, between the quantitative value, objective value, and the qualitative value, which is subjective. Yeah. So you need to balance between quantitative and qualitative approach. So this is where we will have many different methods. Yeah. Later we will discuss Brown Gibson and ASP. So this is part of the how you will put them together, yeah, between the quantitative and the qualitative. Okay, so you need to convert maybe the qualitative assessment, yeah, into the score or ranking so that you can integrate them into the quantitative model. Okay, and after that you put weight to the criteria, yeah, to reflect which factor have certain priority. Okay, so you put some weight in the certain factors. Okay, after that you put scoring, right? So you put scoring for each project and for each factor. Yeah, so you create a table. Okay, and you need to be consistent input the scoring, right? So higher should be better. Yeah. How about if it is cost? Maybe lower should be better, right? So you need to distinguish between the benefit or the gain, yeah, which higher should be better, and the cost, yeah, which lower should be better, right? And then you total the score, yeah, you multiply the score for each criterion by the weight, okay, and then you sum the value to calculate the score for each for the project. Okay, then the total score represent the quantitative measure. Okay, then you run this. Okay, and the last part is you review, okay, what you just did. Okay, and then you is this ranking make sense or not? Okay? Maybe make sense uh, geographically to your region or not. Yeah, so you need to adjust the ranking based on your professional judgment. Okay. Okay, so with that, this is the introduction to what's the next one. Yeah, so we will do a practice of what is called multi-criteria decision making. Yeah, MCDM. So you need to set the criteria, okay, and then set certain alternative project scenarios that you have, and you do the scoring and then compute this. Okay, so be careful if there is what is called rank reversal. Yeah, so the rank will reverse by changing your score just slightly. Okay, with this, let's go to the next topic. MCDM. Yeah. Go to model. Go to the next one. Then I share it. And you see the slide. Did you open your own slide? Also? Okay. So in urban planning, transport planning, you rarely to see a black and white choice. Okay, so urban planning is management of competing objective, isn't it? For example, that is you want a conservation, eh, and then the other one is development. So these are competing objective. Yeah? So you usually choose between a new highway, uh, LRT, and the bus. Yeah? Okay, and then each have different costs, different capacities, have different environmental impact, right? So these are the criteria that you want to do, and MCDM is just a tool, yeah, to justify these choices transparently. Okay, so let's start. Yeah, this is the overview technique that we will discuss in this slide. Okay, I will I will start with what is MCDM, what's the purpose, the goal, criteria, alternative, and I will discuss a little bit the math, yeah, the transformation and normalization. And then we start with the simplest cross tabulation, rank, normalized factor, and finally this is the one that we use, yeah, the weighted criteria of the normalized factor. Okay, okay, let's start this. Okay. So by the end of this lesson, you should be able to make decision based on multiple criteria, yeah, and for your alternative. And then I hope you can identify simple MCDM technique, yeah? And then you're supposed to be able to quantify your objective opinion into measurable data, yeah, for decision making. That's the goal. Yeah. Okay. Let's start with a planning problem definition. So this is the core concept here is you want to do decision making, right? What is decision making? You want to select among the alternative, okay, subjects, and based on criteria. So uh, you have three things there, yeah, the goal, the criteria, and the subjects or the alternative. Yeah, the goal, of course, what is the purpose? Okay? And then you have the criteria. In this case, you need to consider the factors that you want. Okay, the alternative mean the choices, yeah, the subject that you will decide. Okay, I give you several examples so that you will get the idea. Okay, so say let's start with the example of environmental planning example. Yeah, so you want to manage the forest resources, right? So these are the example of criteria that you can set. Yeah, probably the employment, the income, economic, and biodiversity, conserve area, water quality, soil erosion, and so on. Yeah. So and then you create the alternative. Yeah. So the alternative may be ban all logging, or just ban logging in the old forest, yeah, or you permit all logging, or you do nothing. Yeah. So this also part of the alternative option. Yeah. Uh, Similarly, yeah, can you see we have goal, criteria, and alternative. Similarly, you can also have uh, another goal is to select the best office space. Yeah. So in that case, you set your own criteria. For example, the floor area, maybe closeness to the customer, maybe visibility, maybe the image of that area, yeah, maybe comfort, yeah, maybe parking space, and so on. Yeah, and then what is the alternative? Yeah, so you identify the street name, yeah, the name of the vacant space in your vicinity, isn't it? Similarly, okay, this is another example. Say you want to select the school for your for your cousin, your children, or for yourself. Okay, so then these are probably the criteria that you set. Yeah. Again, the one that you set for the criteria is up to you, right? It's subjective to set the criteria, the distance, reputation, maybe teacher kindliness, and so on. Okay, and then of course the alternative are the name of the school. Can you understand now the meaning of decision making? Yeah. You always have a goal and criteria and the alternative. That okay? Yeah. Similarly, yeah. So this is another example again. You want to find the best apartment. Okay. Then you set up your criteria. Yeah? Price, maybe down payment, distance to your work, then maybe uh, how about the neighbor friendliness. And so then the alternative, yeah, or the subject are the list of apartment and consideration. Okay. Again, it's not just for the personal, but you also use this for political selection. Yeah, maybe you will select this. You want to select the best politician, then maybe you will select based on the charm, good-looking programs, yeah, good working programs, and the benefit of your organization. Maybe you are based on the attention to your needs and so on. And then you have a list of candidates as the alternate subject. Okay. If you want to select your top thesis, yeah, the same thing, yeah. So you create criteria and then the list of topics, right? Say if you want to buy car or motorcycle, the same thing, yeah. You set up your criteria and the alternative are the brand name or the type of the car. Okay? So in the industry, so you want to buy or rent the machine. Yeah, so the choice is between rent or buy a certain brand. Okay, then you set up the criteria. So the choice can be only two, yeah, rent or buy, for example. The same thing in transportation. Say you want to find the best alignment of the subway, for example, or the bus route, and then the alternative will be the route. Okay, and these are the criteria you can set up. Okay? So the total cost, the service operation, the interconnection, and so on. Okay, so can you give me your own example then? Okay, what is the goal? What is the criteria and the alternative? Go ahead. Yeah. For each group, at least one. Yeah? Do you understand? You want to decide, right? So then you need to list down your own goal, your own criteria. Yeah. Come on. Group one. You have four groups. Yes. Come on. Yes. Oh, which group are you?
I'm from Group 4, sir.
Okay,
Fourth
group
group.
four. Good.
I think in coordination with our proposed topic on our
Mm-hmm.
last meeting, the electric vehicles, I
Mm-hmm.
think one perfect example would be the selection of the batteries that would be used for electric vehicles. What
Okay.
are the types of batteries? Because there are different types, right? We have lithium
Right.
ion, we have lithium iron phosphate, on which the latter has a higher initial investment but longer lifespan. The battery
Okay.
doesn't
So you have two
degrade at all.
criteria at least in here, right? The
Yes,
longer lifespan in the time and then the
yes.
investment. Yeah. Can you add
Well,
more
well, the
criteria?
well, the first one is requires lower initial investment but requires longer maintenance in the long run. So I think
Okay.
it is a better example for this.
Very good. Yes. Okay, other group. Come on. Based on your own group projects, you're supposed to be able to see this, right? Anyway, along this course, you will see similar. No? So, George, which group are you?
Sir, we are group 2, but my 2
Oh.
members, sir, are absent today.
Okay.
So I'm the only
Go.
one here. Yeah, so as what Paul said about their project, so our project also is about related to the illegal parking. So our goal is to maximize the reduction of illegal parking in the city, which is in Quezon City.
Okay.
Then for of course for our criteria, we have the of course the cost of this the implementation of this reduction of illegal parking,
Mhm.
the enforcement feasibility,
Okay.
the say long-term sustainability,
Okay.
this implementation of curb space that we need to develop.
Okay.
Those are the criteria. The safety also of the pedestrian.
Good.
Then for the alternatives, maybe we will install CCTV or
Okay.
how to increase the towing operation so that we can reduce this illegal parking.
Okay.
Then, of course, increase or maybe we can increase the fines or the penalties
Okay.
to those violators. So those are
So,
the
yeah,
goal alternatives and
possible, right?
criteria, sir. Yeah.
Alternative. Good. So, at least if you understand your goal, your criteria, your alternative, then you start to see. Okay. Later, easily you can just fill up the score, yeah, because the scoring is subjective at this point. Okay. Okay. Next, other group. Group 2, Group 4, Group 1, and Group 3.
Sir, for group 1,
Mhm.
we decided or we're trying to think about another topic which is about the proliferation of motorcycles, especially in the in provinces, in particular the motor rentals.
Okay.
So for this exercise, so our goal is probably one of our goals is the centralization of these businesses of the
Mhm.
motorcycles. So criteria, we can only think of two for now. So same with the previous groups, which are cost, and the first one is cost, of course. Second is the effects on tourists and locals. And for the alternatives, rather than having a centralized hub, we can have probably satellite hubs.
Okay. So, how about the current condition? That's probably one of the alternative, right? To
Yes, sir.
maintain. Yeah.
Okay.
Oh.
Yep.
You need to add more criteria.
Okay, sir.
Okay. Good. Uh, what's the next group? Group one more, right? Is group 3? Is that group 3? Who is the representative of group 3?
Hello, sir.
Yes.
So, in our group, actually, I was uh having a hard time because I'm on formulating the goal because our topic is about balancing the interest of the residents in the subdivisions and the public's interest. So,
That's good goal.
uh, th- but that's not really one-dimensional as a goal. Maybe that's a those two are the criteria,
Okay.
and the overarching goal will be the
So, what are
uh
the criteria and
sustain.
what are the alternative?
Maybe the goal is the sustainable coexistence of the public and the residents in the area.
It seems
Is
you
that
you you still confused between the goal, criteria, and alternative. Is that correct?
The problem would be how to have two goals that are opposing.
That
That's
one become criteria. Yeah.
that becomes the criteria. So
Yeah.
the main goal would be to uh have the sustainable coexistence of both parties, the
Okay.
residents and the public. And the criteria will be to minimize disruption on residents' interests.
Okay.
I can break that down further to security, what else?
Yeah. So you will
Safety.
list down the category that one, and then you put breakdown into more
Yes.
factors, right?
Okay. Then for alternatives, maybe a different configurations or policies,
Yeah.
combination of
You need
policies.
to be more
More
specific.
specific. So in our last presentation, we discussed the scenario having no restrictions. The residential subdivision will be open to public. And the other alternative will be to retain the strict uh,
Okay.
access to the subdivision.
Okay.
And we still haven't formulated the
Hmm.
uh,
Okay.
beyond
Let's
the
pretend
numbers.
that you already know. Okay. The alternative and the criteria. Okay. What I want you to do next is to put scoring after this. Yeah.
Mm.
Okay. So, okay, good. Yeah. Are you sending that? Very good. So, uh, the MCDM that we discuss here is actually have certain limitation also, right? So, be careful when you do this, okay? Because this is actually a temporal constraint. Yeah? That is, this is only best at this point, right? Because you have limited knowledge, okay? So your constraint, your list of alternative, your list of criteria are not exhaustive, okay? So these are the limitation of MCDM technique, yeah? Actually any MCDM, because you are the one who set your criteria and the alternative. Yeah? Question is, what if you add one more alternative? Yeah? Then will everything change? So, okay. So let's do the practice then. Okay. Uh, you set your problem that you want to decide, each of you. Okay. And then you state the goal and list criteria that you want to decide, and then list of alternative. It can be group project, it can be your personal. Is okay. It's fine. Yeah. This is just for your own practice. Is that okay? And I think I have my go to this website and wait, check. Oh, is it not working? The model. AHP. It's that nanti hierarchy process. Then I have the calculator here. And this is the address. It is also in model. Put this in the chat. You can go there. This is MCDM. Yeah, these are three steps. Okay. First, you select the number of alternative and criteria. Okay. Example, I find. Okay. Then click next. Then you keep name. Yeah. What is your criteria? Criteria number 1, 2, 3. Okay. And you put certain weight. Okay. And next, you fill up the score. And for each alternative, for each criterion, you fill up the score and then you calculate. Then it's very simple. Just this one multiplied by that weight and then sum. Then you will get the weighted sum, and from there the highest just sorted. Okay. So I hope this is okay. You can also do this in Excel. It's not so good. So you create your own. Yes, George.
Sir, is there an ideal number of alternatives or criteria for every problem, or we can write how many we want?
Minimum 2, right?
Minimum 2.
You know why?
Maximum, there's
Maximum is up to
okay.
you, but minimum 2, because we said alternative. That means there is always alternative. Yeah? Meaning current condition. Okay? So the first one is the current condition. Yeah? So the base. So, right? And then this is the alternative. So whatever you can say, put here. Okay? Similarly with the criterion, you need to name it here so that. So. Yes, Paul.
Sir, can I have a question regarding the assignment of weights on
The assignment of weight. Yeah.
yes.
This one
For
is just,
example, if we are conducting a multi-criteria decision research, how
mhm.
do we normalize the criterions that have different measurements? For example, the mean score from quantitative surveys versus the number of passenger riderships. Both are quantitative data, but how can we decide that one criterion weights more than the other? Like,
Yeah,
what's the decision factor for that?
right. That is very crucial question. Okay. In fact, different method will have different way to get that, right? But at this point, yeah, later when we go to different method, yeah, ASP, Brown-Pearson, IFN, you will see you have a different way to decide this way, yeah. But at this point, you just decide arbitrary based on your own feeling. Is that okay?
Okay, sir,
At
understood,
this point,
understood.
yeah, at this point, yeah. Later, when we
So much.
already learn a different method, then you start to see, yeah, how to answer this. Okay, because each different method will have different way to decide this. Exactly, that's very crucial problem, yeah, because that's why you can create different method based on that alone. So $1 million question, that. Okay. Good. But at this point, just select subjectively. Example, yeah, you will just say, oh, criterion 1 is the same. Then you put what with 1, yeah. So criterion, this one is 2 times, then or this one is like 3 times. Say, okay. Once you do that, when you click, okay, so 2, 3, 2, 3, 1. Okay. Then when you calculate, it will automatically get normalized. Yeah. Okay. So that the sum is 1. Okay. So, okay. Do you understand the meaning of normalize in this case? Okay, easy, right? So the sum is 1. Yeah? There are many definition of normalization, but in this case, it's just so that the sum is 1. So is it okay? You can practice this problem, yeah? Let's go back to the slide. Okay, so now you want to handle your urban data. Yeah, so you have objective and subjective, right? So these are probably your objective values with this heart metric. Yeah, usually objective values have units. Yeah, can you see? Probably you have economic cost and benefit. That means in PHP, yeah, pesos or US dollar. Okay, maybe you have in transport you have time, distance, speed, flow, frequency. Yeah, how often that pass this part and so on. You have land use. So these are objective values. Yeah? Okay. You also have what is called uh, subjective value, qualitative. So what's the problem with the objective values? Because you have different units, right? So one is using dollar, US dollar, for example. The other one is meter square. So then you have a problem because your criteria have different units. So how are you going to integrate them together? This is a big problem. Yeah. Second problem is a nonlinear utility. Yeah. So increase from 500 to 1,000 meters square probably is valuable. Okay. But increase from 1,000 to 1,500, the same increase, right? Because of 500 meter square, maybe it's less valuable. Why? Because there is a diminishing return. Yeah? So that is what is the solution. Yeah? One way to solve this is to normalize. Yeah. So if you normalize to the value of 0 to 1 or 0 to 100, okay, then you transform this objective value into subjective utility, yeah, between 0 to 100. So then the units doesn't matter anymore, and then the nonlinear utility does not matter anymore, right? Because now all criteria will have the same range. Okay, same thing. Yeah. Second criteria type is subjective value. Yeah? So this is the soft matrix. Yeah? This is based on preference. Yeah? Usually ordinal number. Yeah? So there is no objective of right or wrong. Okay? It's just opinion. Okay? Say, for example, in urban design, you step about the image. You can set 1 to 0 to 100 comfort. Yeah? So again, you can put the same value, yeah? Say normalize. The same thing with visibility. Okay? So the most important axioms here is uh, transitivity, yeah? Logic. Yeah? That means if A is larger than B and B is larger than C, then it implies logically A must be larger than C, right? Okay, otherwise it's illogical. Okay. That's transitivity is important criteria. Yeah? Ordinal number. Okay, and then you need to have certain bound, upper and lower bound, to indicate which one is the best, which one is the worst, and in the same direction. Yeah, all criteria must be in the same direction. Yeah? You cannot put one is higher and then the other one lower, then it's confusing. And then next is the independent criteria. Yeah, so criteria should not overlap or depend on each other. Yeah, so this is also important action. Okay, so once you have this scoring that you put, okay, we need to normalize, right? So then to normalize, you need to transform. Yeah, you need to transform your function. So this is, say for example, you have distance from the city. This is in kilometer. Then you want to transform into 0 to 100. Okay. Then that transformation depends on the whether it is cost or gain. Yeah, decreasing or increasing. That's okay. So these are examples, Visual 8, to show that this is decreasing function. Okay. Then you will have many different functions that you can set. And this is the transformation. This is the visiting number frequency per month. Then you transform that into 0 to 100. So then you can use this example of function. And then another example here is increasing function. Yeah. So decreasing function is cost. Yeah. Increasing function is benefit or gain. So then you can use example of transformation is this function. This is the visual 8 show. Yeah. So the point is, say you have floor area here, okay? Then you need to transform into 0 to 100, isn't it? So then you will use maybe this function. Yeah. So what function to use is up to you, but you need to think about whether it is increasing or decreasing. Yeah. Decreasing mean cost. Yeah. Increasing mean a benefit or gain. Is this clear or not? Yeah. By having this generic the function that is up to you, okay, is make you confused, then later we will start to bound this function, okay, to be simpler. Okay, so one way to do is to do what is called normalization. And normalization means you want to put it into the range of 0 to 1. Yeah, you transform your value, okay? So either with unit or without unit, maybe your opinion, yeah, into certain range of 0 to 1. Yeah. So your opinion have value of minimum and maximum, that is the range. And then you want to transform this into 0 to 1. Yeah. So this is what I use in this slide. Okay. Dissimilarity or distance, I'll put D. Yeah. When you normalize, I will put as delta. Yeah? So that, okay. So just remember this so that you will not get confused. Yeah. Normalization is just transforming the value of whatever variable that you have or the criteria that you have into a range of 0 to 1. Yeah, that's the meaning of normalization. Again, why you want to do normalization? Yeah, because you cannot add distance to cost, right? Different unit. Yeah. So you will have a higher numerical range. For example, the cost is in million, yeah, the safety is indexed between 1 to 5, okay, then how can you combine them together? So that one is unfair because the cost in million will get better result. So it will influence the weight more. In that case, you need to normalize into 0 to 1 so that each criterion have the same weight. And then you set the weight for each criterion. So the simplest normalization is linear. Yeah, so yeah, this one. Yeah, what is linear? Just depending on your value, decreasing or increasing. Okay, that gain mean increasing linearly straight line, and cost mean decreasing straight line. Then you can use this formula. Yeah, so the gain minus the minimum divided by the range. Yeah, maximum minus the minimum. Similarly, if you have the cost decreasing function, yeah, that means lower value is better, then you normalize inversely. So similar to the gain, but now because this is cost, 1 minus the n of the gain. So you get this formula, okay, inverse criteria. Yeah. So to make the positive, yeah, so the denominator uh, must be greater than the numerator. Okay, is this clear or not? So in principle, yeah, if you want to normalize, yeah, remember this, yeah. Normalization is aggregation. This is what is called data fusion, you know. Okay, so of the numbers. So then what you need to do is make them all positive. For example, you have -2 as your index. Okay, then you need to shift them. Yeah, so you add with the lowest minimum to shift them into positive value, and then the denominator must be bigger than or equal than the nominator, so that we will get between 0 to 1. Okay. You can use any function, any inequality to normalize that index. Yeah? So this is one of my makeup function. Yeah, in the website, you can see. Yeah, we can also create this kind of function. Yeah, whatever function it is, you can see that this is. I will get asymptotically. Yeah? It's not exactly 0 to 1, but it will reach between 0 to 1 asymptotically. Yeah. So the simplest is a while ago, yeah, based on the boundary. But the problem is you need to know the boundary. You need to know the minimum and the maximum. You want to use the linear function like this. Yeah. So what happens if you don't know the minimum? So then in this case, you can just divide by the sum of all the score that you have. This is also one way. Yeah. And what happens if you have a negative value? In that case, you can take the absolute value or the square. Yeah. Okay, this is another way. So these are many methods to do normalization. Okay, so I hope by spreading this possibility that does not confuse you. Yeah, you can just take one of them. That's okay. Yeah, but by introducing this, at least you know a broad various method. Yeah, and this is nice. Yeah, the next method is called Bray-Curtis. Yeah, this is based on Bray-Curtis distance. Yeah, this is sometimes called pair normalization. So if you have a pair of indices, which is always zero or positive, but cannot both zero at the same time. This is important. Yeah, cannot both zero at the same time. This is the at the same time. Yeah. So in that case, you can normalize this way. Yeah. So you take the difference okay? And then you take the absolute and then divide it by the sum. So in this case, it will always produce value between -1 to +1. If you remove the absolute value, if you put the absolute value, it will become 0 to 1. Okay, so this is very nice technique, yeah, but you need two values in this case. Okay, so I give you examples so that you will see. And say you have 5 and 7. So if you want to get the Curtis normalization, then you add and you minus. Yeah, 5 minus 7 is 2. Is that correct? This one is 12. Okay, and this is minus 2. Yeah, so and then you take the absolute value, so become 2 over 12. Yeah, that is the same as 1 over 6. Okay, so the value is, if you take the absolute value like this, the value is always between 0 and 1. Yeah, except when both are 0 here, not possible by definition. Next technique of normalization is based on rank. Okay, so let me clean up this. See, if you have ordinal rank, yeah, so 1 to R, capital R here, you can normalize this. Yeah? For example, yeah, original value is between or Likert scale. Yeah? So -2 until +2, right? And then what you need to do is you put them into rank. Yeah. So 1 to 5. So the maximum is 5. Yeah? This 5 is the capital R here. Then you use this formula. Okay, easy. Yeah. So the R, yeah? So 2 minus 1, yeah? 2 minus 1 divided by 5 minus 1, how much? Equal to, this is 1, 5 minus 1 is 4. Is that correct? Yeah, so, no, this is not correct. You need to use this R, not the I. So in that case, what you will do is, from the original index, you convert to rank first. Okay, increasing. So the R is here. So you will have 5 minus 1 divided by, this total, the capital is R is 5, yeah, minus 1. So equal to 4 divided by 4. Yeah, that's equal to 1. So this is the one. Okay, I will convert this one. Here is 1 minus 1 divided by 5 minus 1. So equal to 0, right? So yeah, you get 0. One more, yeah, this one. You have 2 minus 1, yeah, divided by this R is 5, minus 1. That's equal to 1/4. Yeah, this one. Clear or not? So if you have run, you can normalize this way. Okay, up to here, is there any question first? I'm discussing about a different way to normalize. Okay, so you can just choose one of them. Okay. Okay, so that, let's go to the next slide. If you have any question, you just ask. Okay. Okay, let's go. So let's go with the technique now. Okay. We go from the worst until the best. Yeah. Okay. So the one that you put in the I put in the website is the technique 4, right? So, but let's see what we do in the first technique. Yeah, from the basic to the advanced. Yeah. So first we use cross tabulation of MCDM. So this is the simplest technique. Okay, you have the attribute or the factor on each row or each column. Yeah. So and then the choice of the alternative on the other side. Yeah. So if the attribute in the row, the column will be the choice. Yeah. So then you set up the subjective score of the value. Yeah. And then you sum the score of all factor for each alternative, and then you normalize the score. Yeah. This is example. Okay. So these are the factors I put here, and then you have the choices X, Y, Z. Okay. So and then I put the yellow part here is the one that set up. Yeah. You input on your own. And we know the range. Yeah. For each factor, you know the range. So the range is 0 to 5, 1 to 100. This one is -2 and +2, and so on. This is binary from between 0 and 1. So what you will do, the simplest technique, you don't care the range. Yeah. So what you will do, you just sum and then you normalize. Yeah. So you sum all of this. Okay. And you normalize. Is this correct or not? Of course not correct, yeah, because they have different units and they have different range, isn't it? Okay, so this is the simplest technique, yeah, ignoring everything. Okay, you sum and normalize, so this is not correct. Yes. Okay. Okay. Next. Yeah, what's the problem? Yeah, of course not correct. Yeah, different range. Okay. So now because you have different range for each factor, you can put your own subjective score and you can put your own preference, right? So what's the problem with that? Yeah, it's not clear which one is, what's the meaning? Yeah, is this gain or cost, right? So you mix up everything. Uh, uh, Higher better or smaller is better? You don't know because you don't see this. Yeah, and then each factor have different unit. The change of unit will have different score and different weight. Then each factor also have different range. Okay, so clearly this is incorrect. Okay, if you use this, you are in trouble. Yeah, yes, it's transparent. You set up your score, but at the same time, people will start to criticize. Yeah, with this. Yeah. So then, what is the better way then? Okay, let's normalize the score for each factor. Okay, and start to put weight for each factor. And you need to have more consistent meaning. Yeah, is this benefit or cost, right? Benefit mean higher is better. Yeah? Cost mean lower is better, isn't it? But you cannot have both, correct? And then you need to put you probably want to put the rank rather than subjective score. So let's try this, okay? Okay, let's try this. A while ago, we have this number, okay? In that case, let's put into rank, okay? So let's put this into rank instead of numbers. So by putting everything into ranks, into numbers, so you have exactly the same meaning, isn't it? Okay, so if you put the rank into number, so this is the rank for each for factor A, you have rank 1, 2, 3, yeah, 1, 2, 3, and so on. So these are the value is in the rank, right? And then this is the second technique, right? Rank base. What you will have based on that rank, so you sum and then you normalize the score, right? So this is probably your choice. So you will say, oh, this is choice Y and Z is 36%. Okay, and this is how you compute. Yeah. What's the problem with this technique? Yeah. It's better than the first one, clear. right? Because the first one, you ignore almost everything. Okay, in here, you have the gain and the cost is clearer. Yeah. And the unit, you don't care because it's already run. Okay. So, oh, maybe you will ask, why don't we use this one? Yeah. Uh, we don't use this one. Why we use this? And why we have half here? Yeah. Because we have three alternatives. Yeah. So the actual normalized score should be like this. Yeah? N is the number of alternatives. Okay. If you want to use this technique, so you use this formula. Okay. Normalized score for this one. Normalized score at the bottom. Is it clear or not? So next, you probably want to transform your subjective score into rank, and then you normalize. Okay. And what will be your decision alternative? What is the percentage? Okay. And what is the pros and cons of this rank-based technique? Any idea? Yeah, the weakness of this is actually you lost the magnitude. Yeah. So say you run this three highway route for safety, example. Yeah. So then you lost the magnitude because you run them, you put from the ratio type or interval type, quantitative into qualitative, yeah, ordinal. So you lost the magnitude, yeah. That's the cons of this technique. Okay. So then another way is to linearly transform the score for each factor into 0 and 1. So you can use this formula, yeah, to transform all factors, yeah, into the same range of 0 and 1. So this is better. Okay. So original value here in the here is symbol score. This is the original data. Okay. Then you change because you know the range, so you can compute into value of 0 to 1. Yeah? So in this case, you will get these values. Yeah? So this is the value between 0 to 1 for each factor, for each choice. Yeah? After that, what you will do, because this is already normalized, yeah, for all factors, okay, and then you can sum this, and then you can normalize this again. Yeah? This is just this one divided by the sum. Yeah. So then you will get a better result. This is what we use in that calculator in the website. Yeah. So we normalize first, okay, and then we use multiply by the weight. Yeah. Why we multiply by the weight that you said? Yeah. Because sometimes you need to see that certain factor is actually more important than the others. Okay. So how do you decide the weight? Yeah. So one way to decide is through pairwise comparison. Okay. So you take two of the factor and then compare. Okay. So not all factors are equal, right? So then you need to judge, yeah, the importance of one factor relative to the others. Yeah. This is the professional standard. Yeah. In planning, you require the weight differently because maybe each stakeholder value will have different value. Yeah. Okay. So this is example. Yeah. Say we judge factor B and C are 2 times more important than D. Yeah, so, and then factor A is 3 times more important than factor B. Okay, let's put that into numbers. Right? Okay, so you said B, yeah, yeah, equal to 2 times of D. C also 2 times of D. But A is actually 3 times of B. Okay, this is your judgment. Yeah, subjective, this one. Yeah. Okay. So then what you will do? Oh, that could I just put arbitrary number 1 in D. Yeah. So this is 1. Right? So D is 1, then multiply by 2. B is become 2, and C also 2. And then because this is already 2 and this is 3 times, so this one becomes 6. Easy? Yeah. And then you normalize. Yeah. So you just sum 11 total. Right? So this one is 6 divided by 11. Yeah. So in computing your grade, yeah, I use Fibonacci weight. Yeah, the same. So the first one is 1, the second one is 1, the third assignment become 1 plus 1 become 2, the fourth assignment become 1 plus 2 become 3, and so on. So I then divided by the sum. Yeah. The weight divided by the sum. So you will see similar weighting factor. Okay. Now, in that case, now you can set up your own subjective judgment for each factor that you set. Okay. Okay. So after that, you can get the result, right? The one that you set up in the website. Now, there is what is called swing weight determination. Yeah. So to reach the efficiency, you want to reduce the number of pairwise comparison, right? So in that case, what to do? You sort from the best to the worst, okay? And then you just set the best one as 100, okay? And then you compare the others as the percentage of the best. Then you normalize. So this is a simple technique to get the weight. Yeah. Say for example, yeah. So you first you sort them, yeah, in the order of importance, right? So E is the larger than B, C larger than D larger than B larger than A. So you put that here, yeah. Maybe I put this color red. Okay. So this is the in the based on the rank. Okay. And then what you will do? Then you put this one 100. Okay. So you set up. Okay. So the best factor is 100. Okay. And then the next one you compare. Okay. The worst factor to the best factor. Okay. So the worst factor is what? A. Yeah. A is how much? Okay. Oh, A is like 40% of E. Yeah. So then you said 40%. Then you said, okay, how about P? Yeah. Of course, P must, because this is already the worst, this must be increased, right? Right? B is, yeah, maybe 60% of E. How about D? Yeah. D is 70%. And then how about C? C is like 80%. So this is what you have Yeah, this is the result of your subjective judgment. But easier, right? To just this compared to you compare each of these combinatoric E compared to C, E compared to D, C compared to D, and so on. So become too many. And this is a less comparison. Yeah. Then of course from here you can just normalize. Yeah? Okay. So because you get the sum is 350, so you just divide. Yeah. So you get the result. This one divided by 360, you get 29, and so on. So you get the normalized weight. Okay. To answer your question a while ago. So a while ago you asked how I decide the weight, right? So this is one way to decide. Yeah, you still do a subjective judgment, but it helps you to create. Yeah. So instead of uh, do pairwise, okay, you can also do swing weight. Is this clear or not? Yeah. Eventually, you get normalized. Yeah. Once you know the weight and the normalized score, then you just sum. Yeah. So this is the example. Yeah. So you get the percentage of weight. Yeah. And this one is already normalized, right? Then you just multiply. Yeah. This is some product. Yeah. The weight and the choice. Right. So you get the score. Okay. And then from there you normalize again. So you get this like probability. Okay. So then you will choose the highest, of course. So you will choose Z, yeah, is larger than Y is larger than 10. Yeah. So now you get the winner, Z, in this case. Yeah. This is exactly like the calculated in the web a while ago. Uh, do I answer the question? If you have any comment, question, do I confuse you or not? So this is different way of MCDM. Yeah. Yeah. Any question? So of course you need to do what is called sensitivity analysis later. Yeah. So this is to validate your result. Later you will do what is called sensitivity analysis. Yeah. This is to determine the robustness of your choice. Yeah. Say, for example, yeah, after you have the project choices that you have, okay, and then you do what is called public hearing. Yeah. So say if you prioritize cost over the environment, okay, does this prefer route change or not? Okay. So if the answer is no, then the plan is robust. Yeah. If the answer is yes, then that decision is sensitive to political priorities. And so if you change certain weight, what will happen to your decision? Yeah. If the rank reverse or not. Okay. So in that case, you try to change your weight, okay, slightly, okay, and then see what is the score and the rank. Yeah. Are they changed or not? Yeah. Are they reverse in the rank? Say, for example, first time you have A, B, and C. Yeah. But you change a little bit the weight. For example, some by changing 0.1, and then suddenly A not no longer number one. Yeah, maybe B is number one. So the rank reverse. In that case, this is sensitive Yeah. So it's not robust enough. Okay. So that is how you do sensitivity analysis, yeah, to check the robustness of your scoring. Okay. So anyway, later on when we do an IFN, you will see better result of the sensitivity analysis. Yeah. So at this point, this is the uh, summary of what we have today. Yeah. So first, you identify who are the stakeholder, yeah, the decision maker. Okay, and then you identify the alternative, the criteria, the goal. Okay, and then you set up the attribute. Yeah, for each attribute or the factors, you assign the value. Okay, after that you uh, determine the weight for each attribute. Yeah, and then from there you can take the weighted average, for example, and then make the provisional decision. Yeah, and perform sensitivity analysis to check the robustness of this. Yeah, so this is the general idea of what is called MCDM. So up to here, is there any question? What general idea of MCDM? So you have the calculator also there, so you can just use. Okay, and you have assignment also later on, right? Individual, I think. Uh, oh, no more time. Yeah. So in that case, yeah, we have only 7 minutes. I don't think we can finish bracket sum in 7 minutes. Okay. So question and answer. Go. So in that case, next week we will discuss bracket sum and uh, AHP. Yeah. So you read the slide first. Okay. And the following weeks we can discuss the IFN for prioritization. Okay. Okay. For MCDM prioritization knapsack. Any question? And what did you learn? So share what you learned today. Go ahead. Yes, George.
Sir, actually, this is not a question. This is only a suggestion, sir,
Oh,
because
okay.
our class, sir, actually runs for 3 hours straight, and sometimes we or I really need to have a quick water or washroom break.
Okay, okay.
Then
So
last
we
time,
stop.
yeah,
Yeah.
last time actually, sir, when you were discussing about this linear programming in Excel solver, so it's actually a step-by-step process. So if you miss one part, it's actually difficult to follow the next step. So
Okay.
last meeting, I went for a washroom break or a quick water break, so I didn't follow the the next step. So I would suggest, sir, if possible, we can have at least a 3 to 5 minute break
Sure,
after
sure,
1 hour.
sure. You remind me if you want break, so that we can.
Okay,
Yeah.
sir.
Number one.
Thank you,
Then
sir.
number two, you have the recording always.
Yes, sir. Actually, I need to replay, but I
Yes.
need to find actually this topic that I need to repeat it again.
Okay.
It's different from actual discussion.
Okay. Okay.
So
Okay. So you remind me if you want to a break, then I can stop, and then we have a 5 or 10 minute break, and then we can continue again. Yeah, no problem with that. And then the recording is always there in the Moodle and in YouTube. Yeah, so you can always check that. Okay. And yeah, Paul, you want to say something?
I think more than just I just want to confirm if MCDM and prioritization can be used together.
because based from what I have digested in tonight's lecture, I think MCDM is the perfect way in identifying the activities to be prioritized or the options that would be considered if there are if there are several constraints present.
Right, right. So this is the simplest technique we discussed today. Okay, and as we discuss next week and the following week, you will see a little bit more complex, okay, than this one because this is just linear, right? Everything just normalize and then put the weight, okay. And next week when you see brown gauge sound, we separate between objective and subjective values, okay, and we use different method, yeah, uh, to combine them. In ASP, you have hierarchy, and you use pairwise comparison. Okay, so and then in IFN prioritization, that one I developed by myself, but that one is using flow, yeah, network flow. Okay, and uh, in IFN, you don't need to put the weight, yeah, automatically set up the weight by itself, and you will later also see uh, there are some theory behind that to connect between the IFN and ASP, okay, and also to connect between the IFN with the physics, yeah, uh, Markov chain and physics, okay. So then you start to see we have many different methods, okay. Of course, this is the simplest. Yeah. Today is like very simple technique. Yeah. Well, knapsack is not simple. Okay. And then later you will see we can compare. Okay. And then you will appreciate that knapsack itself is actually stand on its own, yeah, better than the others. Okay. Yeah. Because you have certain optimization there. Yeah. Okay. So at this point, you will see MCDM is one of the simplest technique. You just normalize the weight, and then you multiply, and then you get this weighted sum. Okay, and then you get the rank. Okay, if this simplification work for you, okay, or for your clients in the government and so on, then use this. Yeah, but if they already know better technique, and you will see that there are some advantage of other technique, then you can use that also. Okay, so which technique you use, that depends on you, yeah, and your clients, of course. Okay, any other discussion that you want? What did you learn today? So aside from this, yeah, I hope this is useful enough for your life. Yeah, Andrew.
Sir, question about uh packaging all these tools you discussed. So, the linear programming or prioritization or knapsack problem tool we did only identifies the items that are inside that can be accommodated in a constraint. But we actually haven't sorted them out. So is the MCDM the way to sort them out? Is
Yes,
that the
yes.
okay?
So in Knapsack or in LP, linear programming, you have the objective function and the constraint. Okay, but you don't know which one to prioritize. So MCDM is the technique to prioritize.
Okay.
Okay, so you will
And
know which one to choose.
then our knobs in uh sorting them out are the weights.
Later we'll have different techniques. This
The
is
different. Okay.
here, yeah. In here, you just set the weight, okay, and scoring that you set,
Okay, sir. And
okay.
lastly,
Mm.
sir,
Yes,
uh
yes.
you mentioned an Excel add-in, the antecedents.
Oh, yeah.
How
That one
how
is
might we
Hmm?
How might we get a hold of
Why
her?
why do you need that? So
Just interested.
yeah, but that's yeah, if you are interested, you can DM me. But at
Okay.
this point, you don't need that because you already have the software,
Hmm.
right? So you can also use Knapsack. Yeah.
Okay, okay.
So that one is for people who does not know Knapsack, and then they
Ah,
want convenient for their daily tasks. Yeah. For me, I'm just using it for myself. So
okay, okay.
okay. I know this is a very excellent optimization, Knapsack. Okay, and then when I say this, and then I start to try to optimize my own productivity. Okay, so that's why I created that. Yeah.
Thank you, sir.
Okay, so thank you. Yeah. So thank you for today, and see you next week. Yeah. We still have class, right? Next week. Yeah. Good. Thank you. Okay. I hope this is useful.
Thank you, sir.
Yes.
Thank you,
Bye.
sir. Bye, sir.
Bye.